Hi everyone, thanks for watching this video. This project is entitled, Chemical Plant Design Project for Future-Ready Holistic Chemical Engineering Graduates. The project is conducted for the final year students of the Bachelor of Chemical Process Engineering in Malaysia Japan International Institute of Technology MJIT. Based on the top 10 skills of 2025 defined by the World Economic Forum, the critical core skills identified by Skills Future Singapore, soft skills as the graduate attributes by the International Engineering Alliance, and the 7 graduate attributes at University Technology Malaysia, UTM. It is becoming increasingly obvious that soon-to-be graduates should be equipped with a bank of soft skills besides just having a degree from higher learning institutions, as all of these are necessary for today and future workplaces. On the other hand, complex engineering problems are frequently introduced in the chemical plant design project for chemical engineering programs across the country. Unfortunately, many of these projects are lacking of actual industry-related problems, stakeholders' involvement, and engineering educators frequently fail to design complex engineering problems to assess students' mastery of the skill. In MJIT, the implementation of the previous model has led to fragmented learning, and students cannot connect and apply what they have learned in the classroom to a real-world scenario and to solve the complex design problem. In addition, the learning in the project heavily depends on the efforts of the respective academic lecturers or supervisors, that learning experiences between different student groups may differ significantly. Lastly, the assessment lacks robustness because the majority of the assessors are academic staffs, who are frequently inclined to prioritize the application of fundamental and textbook knowledge. The Chemical Plant Design Project aimed to groom future-ready holistic chemical engineering graduates, who have great mastery in chemical engineering design knowledge and strong soft skills, especially to work in a team, be ethical, present well, write good reports and manage projects. The Chemical Plant Design Project provides authentic and open-ended problems to the students, in which the students are required to propose a specified chemical plant to be designed by the allocated project team. The team must propose the specific project title within the provided scope, based on their preliminary studies, the real markets, preliminary economic assessment, potential safety issues and sustainability considerations. The Chemical Plant Design Capstone Project in the SMJSE curriculum acts as the holistic alternative assessment to the delivery of the theory class. The intended course learning outcomes in the teaching and learning activities are constructed aligned with the project's deliverables or assessment. The learning outcome mainly consists of technical design and knowledge, environmental awareness, communication, teamwork, project management, ethics, and lifelong learning. This curriculum design heavily highlights the concept of assessment as learning while maintaining assessment for learning, and assessment of learning. This slide shows the constructive alignment of the Chemical Plant Design Project. Instead of the conventional method with process design class and plant design project as a separate module, the students' learning experiences in the current model are led by standardized project milestones, problems and facilitated by the evaluation rubrics provided at the beginning of the semester. Based on the project milestones and rubrics provided, the students would be able to generate inquiries along with the project's progress. Therefore, the classroom teaching and learning activities are planned to be provided based on students' inquiries, which provide in-time support and scaffold during the assessment. As a learning process, this is known as horizontal curriculum integration. In addition, various student-centered learning activities are conducted throughout the semester following the project milestones. For example, the chemical process design heuristics were delivered via a modified jigsaw teaching strategy. In addition, practicing engineering are invited to deliver industrial guest lectures, reinforcing the importance of professional engineering practice and providing an up-to-date practice in the industry. The multi-perspective alternative assessment model is used in the project for the holistic and comprehensive criteria assessment, which involves self, peers, academic supervisor, industrial supervisor, internal lecturers, external lecturers, and industrial panels. Furthermore, the project implementation is based on cooperative learning theory, in which individual accountability and team processing are required to devise a solution. This would create students to do self-reflection and peer feedback in the team. Non-graded formative assessment. Meanwhile, the academic supervisor regularly provides in-time feedback to the project teams. Non-graded formative assessment, during regular meetings while ensuring the project progress as planned. In addition, industrial supervisors are appointed to meet regularly with several design teams, which are expected to provide authentic feedback. Non-graded formative assessment. To ensure the projects are practical, multiple assessors are appointed for all graded formative and summative assessments to ensure a reliable assessment and the absence of bias, such as primacy bias, leniency bias, halo or horns effect bias, and centrality bias. The internal lecturer or supervisors are not assigned to mark the reports as a whole. For all the reports, 2 to 3 internal lecturers are appointed to evaluate 2 to 3 criteria in the assessment rubrics. In addition, there are various presentation sessions as formative and summative assessments for the students, which 2 to 3 lecturers are assigned to evaluate and provide feedback to the teams. To train holistic future graduates, the assessments in this aspect have a significant portion on soft skills development, 47.5% of the total graded assessment, focusing on environmental awareness, engineering ethics, teamworking, communication skills, and project management and finance. These are essential skills for the students to ensure they can adapt to their future as engineers. The self and peers assessment and the academic and industrial supervisors assess the team working element in the project. They have the most reliable role in observing students' attitudes and behavior through regular meetings. This project's communication skills are divided into the presentation and report writing skills. The presentation skill is receiving non-graded formative assessment during students' regular meetings with academic and industrial supervisors, which academic supervisors also conduct rehearsals before students' graded presentation assessments. The presentation skills will be improvised through 4 presentation evaluation sessions with internal lecturers, external lecturers and industrial panels. Some of the parts of the reports are going to be resubmitted and re-evaluated, which provides opportunities to improve students' report writing skills. In addition, free riders are always a major concern in project-based learning. Self and peer assessment was done regularly on our students, which include a modified professional behavior instrument and open-ended questions. The self and peer assessment promotes social skills and positive interdependence in the cooperative learning principle. The reliability of the self and assessment instrument was investigated by Fu and Liu in 2020 and concluded that the self-assessment results converge with the peer assessment results after a few self and peer assessment cycles with appropriate training. The assessment comments are returned to all the students as feedback, which the coordinator takes the opportunity to share about human behavior, attitude, teamwork and toleration. Besides that, the coordinator reviews the assessment comments to observe the design team. The design team with communication problems, an intervention would be introduced when it is found. The coordinator would consult with the academic supervisor and meet with the design team to provide an opportunity for them to speak out about their issue openly in the team. In order to reflect student contribution to the result, the self and peer assessment results are integrated into the team-based assessment, such as report, presentation and project management, via auto plan, do, study, and act. PDSA model is used for continuous quality improvement, CQI, in the subject. The development of this chemical plant design project model is based on the comments from various stakeholders, engineering accreditation council auditors, external examiners, industrial advisory panels, industrial supervisors, industrial evaluators, external lecturers, academic supervisor, alumni and students. The chemical plant design project has enhanced students' soft skills development. The top table shows the average achievement and professional behavior development or team working from 2018 to 2022. In average, The 4 cohorts have shown improvement in the 3 self and peer assessments within a year. Furthermore, the number of individual students who have improved in their self and peer assessment has also increased from 64% to 83%. This is an excellent indication that the project allowed the students to experience and improve their soft skills. The lower table summarizes the average marks of SMGSE 43-43 and SMGSE 48-24, a drastic change in the achievement of SMGSE 43-43 from 2016 to 2017, in which the subject transformed from a typical lecture class with a final examination in 2016 to project-based learning in 2017. In 2021, the design committee made significant modifications to the evaluation rubrics, which aimed for more holistic and representable rubrics for the students. In addition, the committee trained the assessors to ensure reliable and fair assessments were made. This caused the achievement in 2021-2022 to drop for both subjects. Interestingly, the difference in the average scores between SMGSE 43-43 and SMGSE 48-24 has reduced in 2021-2022. Which proves that the assessment and their rubrics for both subjects are more representatives because they are based on the same project. Over the years, the team has published a journal article in the International Journal of Engineering Education, about the reliability of the self and peer assessment in chemical plant design project. Lately, one article is accepted by the Journal of Chemical Education, on the emotional intelligence and psychological capital of the students in the project. The project also won a gold medal and a silver medal in the NALI competition in 2020. The project has also been recognized by the Active Blended Learning Course Awards across the years. Lastly, the team has copyrighted the design and evaluation of the chemical plant design project model, which could be used by other chemical engineering programs across the world. Thank you very much for watching this video until the end. If you have any questions, please do not hesitate to contact us.